Okay, just a video of the Alpha 76 with three 8874s. These tubes are hard to get and expensive, so some people, don't even deal with these amps because of the tubes. But basically, here it is. Hyperseal plate transformer, big oversized transformer for it. The power supply, high voltage there. Those are the high voltage diodes. Uses a full wave bridge, and each of these single diodes packages are 3000 volts. And how they do that is they put three regular diodes in one package and seal it up. So each of these legs of this bridge are 3000 volt diodes, and it's in a full wave bridge. The high voltage capacitors are screw in, old style screw in over there, and that's where they're screwed in. You see the screws there. It has 6 450 volt 210 UF capacitors on it. These resistors on top are the bleeders. And then this the low voltage and bias stuff over here. It's got a pi L output, meaning it's got the power coming off the tubes and into the tune cap over here, and then into this coil, which is tapped for the different bands, and then into the band switch here, which also controls the taps. But then it goes into one of these coils. That's a tap coil for like 10, 15, 20 meters, and then for like 40 and 80 you switch in those coils because you need more inductance. So a pi circuit, which most amps are a capacitor, tune cap, coil, load cap. Where a pi L is the same thing, but it adds another coil or inductor at the end of it. That's the L circuit, is the inductor at the end. So a pi L gives you a little bit more efficiency, so the tubes are put a little bit more out with the efficiency, and they're cleaner too with the pi L circuit versus a pi. Most linears, especially CB, aren't going to be pi L circuits, mostly because of cost. I think a lot of CB amps, they make them I guess thrifty, or cheaply is another word on it. Got the blower, got the rubber chimneys that take the power up into the cover if it was on and out, instead of in the chamber heating everything up. Let's see, over here you got one safety circuit. When you take the cover off, triple check that I'm unplugged and I know I'm drained before I go to touching stuff. So anyway, you take the cover off, and this switch here is an interlock. When it's down, it engages the switch, so it'll power up the transformer. That's in one of the windings of the transformer. And then when you take the cover off, it opens one of the windings of the transformer, so it removes voltage, and it's trying to keep somebody from killing themselves. Makes it dummy proof. That's a safety feature. And here's another one where on the high voltage comes up to that screw there, and I'm not touching that even if it's drained. I'm going to use this screwdriver here, and with the cover on, it pushes down and it's not touching that screw, and lets the high voltage, it's open circuit. But you take the cover off, that metal strip is hitting the screw there, and it shorts out the high voltage. So if I powered this amp up with the cover off, and that's one reason I didn't show it, because I didn't want to deal with the interlock and the cutoff switch there, the shorting switch. First you'd have to engage that, but with that like that, it would short out the output. So that's another safety thing. This inductor right here is also a safety inductor that many CB amps do not have. And all that is if these capacitors right here that have the high voltage here on the tubes and the RF going through them, and these are called plate blocking capacitors, and they block the high voltage in DC, and they only allow the AC or the RF to pass through. Again, they block the DC. But if they short or leak, but mostly short, that high voltage is going to go past here and through these caps and into all the circuits and into the output and possibly kill somebody. So this safety choke is the opposite of that cap. It'll let well, it's actually the same thing. It'll let RF go right past it. But if DC, you know, gets through there from that cap shorting, that cap is connected from, or that inductor is connected from the output to ground. So it'll short out any DC that happens to go past there. And again, when it shorts that out, it should blow the fuse and stop the transmit or stop the amplifier from working. And again, a safety factor. Whereas, and that's its only purpose, is the safety factor. And a lot of CB amps don't have that, and hence that makes them a lot more dangerous, because again, you know, stuff does break, stuff shorts, especially these blocking caps. They got, you know, what's this amp run on? 2300 volts on them anytime you power this amp up. Plus the RF, you know, goes through them. So it's a lot of stress or power that happens to those plate blocking caps. You'll often see some amps have doorknob caps, which are actually a stronger cap, but this got two good sized caps in parallel there. So I guess that's about it. All I wanted to talk to about this amp. You can run it. It's got a terminal strip there, and it's got a couple more jumpers for 110, and you move the jumpers around, and you got extra jumpers you put in there for 110. It'll run on 110, or on 220 you just need the one jumper there, and I was running it on 220. So that's it of my latest toy, this Alpha 76. It's either a PA or a CA with the 3 tubes. I think it's a CA with the heavier transformer, even though it just says 76A. But that's for it for this one. I like it. Don't love it, but I like it. All right, that's it for this one. Bye.